Basic idea is this, that if x is less than equal to m and y is less than equal to small m, or let's say m1 and m2, then it implies that the maximum of x comma y will be less than equal to what? If you have two numbers and you know that, okay, let's put into words instead of algebra. Let's say you know that the maximum you can score in two tests, your you can score maximum in your probability 1 course is 79 out of 100, and the maximum you can score in your statistics 1 course is 85 out of 100, right? So what is the maximum possible score you can have in both of them? In one of them is less than equal to nothing but is what?
100.
No, the maximum possible score of, uh, listen to me carefully, maximum possible score of 100 is of course a maximum bound but not the best upper bound. So maximum possible score of yours in probability 1 is 79, and you can get at max maximum, and the maximum possible score in statistics 1 is 85. Then what is the maximum possible score that you can get in both of them? What is the maximum possible score you can get of both of them? I mean, yes, tell me. What do you think?
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning.
The question is very simple. The question asks that if an is the limit of an, says that limit n tends to infinity an is equal to L, and Bn is less than equal to L, then asks that prove that if limit n tends to infinity, max of an comma Bn is equal to L, and they named it Cn. This is a problem they're trying to solve. Now let's again try to apply these methods that we have learned today. And we will not use epsilon delta. We will use simple sandwich theorem. Okay. Sandwich theorem is very simple. So max of an and bn is less than equal to. So you know the max of an is greater than equal to what? An, right? You know that max of an is greater than equal to an. Now understand this very carefully. Now if you close your eyes and try to imagine this thing, the an is going to the limit L and bn is less than equal to L, right? An is going to this limit L and Bn is less than equal to L. So if you take any maximum of this at any point, that means what? And that's where the whole sandwich theorem is required. So whole epsilon delta is required. The basic idea is this: understand when you understand that when you have to use epsilon delta. So it's saying that, let's take a simple example. This is L. A sequence is going here like this. Just give me a minute. Like this, okay? And you know that another Bn sequence is less than equal to L. You do not know how it is. It can be like this also. It can be like this. Uh, you do not know how it is. So what do? You take this style like this. Now the question it's asking that if you at each of these points you will get another Cn, right? For example, here, let's say this is, so if you take this, define this new sequence, you can see that at all of these points Bn is large. So at every point you take the maximum of this two. Now here you see, oh, this is becoming the maximum. Then so you take this red sequence now. and again here this becomes a maximum, and again here this becomes a maximum. So you see, naturally, this is the sequence. So this is what is meant by the maximum sequence. All of you understood this? This is what is meant by the maximum sequence. So now it's asking that it goes to the limit, the same limit as what an is. The reason is very simple, because you know that an is going towards L and bn is less than equal to L, right? So at every point an and bn, the bad part is that an cannot be, understand this very carefully, an can be also coming from above. An can also come from above like this, right? An can also come from above. So the best part is this. So what you do is that an can also come like this. You can understand. It can also happen like this. So let's take another example where that happens so that you understand it very, very carefully. So we are taking now simpler examples and understanding the whole scenario to get an intuition, right? And this is the part of problem solving that I've discovered, that we have talked about today. So let's say this is bn. I don't know why I'm not being able to get that option of I got it. Let's say bn is like this, and now let's take an. Now an is like this, let's say. So if you observe it very carefully, that at this point this is the point, at this point this is the point, this point, this point, this point, this point, this point, and again here this point, then again this comes this, then this, again this becomes the maximum, this becomes the maximum, then this becomes the maximum, this becomes the maximum, and then it goes, right? So what is happening here is this, that understand there are two cases. The good part is that the max of an plus bn, there are two things happening. One is above, since bn is less than equal to L, understand the max will be only greater than L if, and if max is greater than equal to greater than L, this implies that an is actually greater than L because bn is less than equal to L. You understand? If the max at a certain point is greater than L, it can only happen if the an is actually greater than L at that point. And because bn is always less than equal to L. All of you understood this, right? If otherwise, and vice versa, if n is greater than L, so this observation that we have got, that n is greater than L, if and only if max of an comma bn is greater than L. This is what the observation is. Let's call it equal to, right? That means, can we say that if, rather I would say that if n is greater than equal to n, not only this, the max is actually equal to an. Do you understand this, guys? If an is greater than equal to L, even only if, not this, sorry, L, and therefore max of an comma bn is equal to an. Does it make sense? So this is the basic concept. N is greater than equal to L if and only if max of n plus and n and bn is greater than L, and this implies that max of n and bn is equal to an. Why? Because bn is less than L, less than equal to L, and n is greater than L. So naturally max will be an, right? Now why this is good? Because in sandwich theorem we want what? We want that max of an bn we know that an is going to L. So if somehow we can bound it on both sides by n or similar to n, that will be great. So what we get is the following. Understand this. So therefore, we see that everything is, the whole maximum is dependent on being an being greater than equal to L or not. So there are two cases. If n is less than equal to L, there is one case, and n is greater than equal to L, there is another case. If n is less than equal to L, we know both an and bn is less than equal to L, right? And both of this bn is less than equal to L. We know that in this case, maximum of a and bl will be less than equal to maximum of L and L, that is L. If you know that in both the subjects you will get 79 at max, you know the maximum score you can get is 79, right? So this is a very important concept. All of you understood this?
How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI MStat, and CMI MStat data science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI MStat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.